Let's imagine a database designed specifically for real-time AI, one that scales automatically, stays online 24/7, and can serve millions of requests per second. That's what RonDB delivers. Developed by Hopsworks, RonDB has just released version 24.10, which includes 11 new major features that take speed, scalability, and cloud readiness to a new level. In a moment, we'll talk more about 24.10, but first a brief introduction to RonDB.
RonDB is a high-performance enhanced key-value store with SQL capabilities designed for real-time AI workloads. RonDB's SQL capabilities, along with its other unique features, allow users to implement and accomplish many things not possible in conventional key-value stores. This includes pushdown aggregation, nested left joins, and more. A key-value store assigns a unique identifier or key to a set of values. Using keys provides easy storage, retrieval, searching, and updating of data using simple queries. Key-value stores are ideal for organizations with large volumes of data that need to be constantly retrieved and updated. RonDB's enhanced key-value store is distributed, meaning that RonDB operates over several locations or sites, such as a network of computers. Distributed key-value stores are particularly useful for organizations with heavy read and write workloads on large data sets, making these systems fit for organizations that operate at scale.
First released in 2021, RonDB was created by our head of data, Michael Ronstrom, along with the Hopsworks team. We built RonDB specifically to support real-time AI workloads at scale. There are a number of ways RonDB exceeds the capabilities of other key-value stores for AI workloads, and we're here to discuss how. RonDB is a LATS database built to meet the demand of high-performance, mission-critical applications. LATS stands for low latency, high availability, high throughput, and scalable storage. Real-time AI systems demand a LATS database such as RonDB. For example, modern e-commerce and entertainment websites now provide personalized recommendations powered by AI that will fail if the underlying database fails. With a LATS database like RonDB, you can reliably power your most important and valuable AI services at any scale. Let's take a look.
Number 1. Low latency. RonDB's low predictable latency is ideal for real-time systems, such as an online machine learning model, systems that respond to user activity, or power systems that demand instant decision-making. RonDB completes requests quickly and reliably, even at high workload. Joins and projections are two very common SQL operations. In RonDB, we have implemented left join pushdown and projection pushdown. These operations are executed by the query engine efficiently, instead of delegating the task to the API, such as a MySQL server, providing low latency and high throughput for complex queries. Additionally, RonDB delivers high performance consistently, even under pressure. It maintains predictable response times, even when the system is running at over 90% capacity. By holding data in memory and committing transactions across multiple nodes at once, it ensures both speed and durability. Moreover, with CPU cache optimized data structures and smart batch processing, RonDB can handle complex, multi-row transactions in just milliseconds.
Number 2. High availability. RonDB has class 6 availability, meaning it is operational more than 99.9999% of the time. In other words, downtime will average about 30 seconds per year or less. To achieve such high availability and protect users' data, RonDB is built to safeguard your data from both internal and external disturbances. Data is replicated within a cluster, so if one data node fails, another node can step in and take over the failed node's responsibilities. Thanks to a specially designed takeover protocol, this happens automatically and seamlessly, and it will not interrupt the flow of data or cause any downtime. This ensures that your application continues to run smoothly, even if some parts of your RonDB cluster were to fail. So, what about power loss, natural disasters, or other major events that can take down an entire cluster? RonDB supports replication not only within the cluster, but also across clusters in different regions, and in the cloud also in multiple availability zones in one region. This ensures that your data stays protected in any scenario. With RonDB, you can rest assured that your data will remain accessible and safe.
Number 3, high throughput.
When creating RonDB, we knew that it needed to have a high throughput. RonDB is able to take in tens of millions of requests without any problem, and even scales to hundreds of millions of requests per second. RonDB scales in every direction, from threads within a CPU, across multiple CPU cores, to multiple nodes in the clusters. Data nodes within RonDB can be accessed from a large number of MySQL servers, making it possible to issue tens of millions of SQL queries per second for the same data. We also created what we call query workers into RonDB. Query workers make it possible to read a partition from multiple threads at the same time, increasing RonDB's scalability without having to create more partitions, reducing load on the system and improving latency. We built RonDB to ensure high throughput and low latency, even when under an extreme load. Whether you are running real-time inference, batch pipelines, or multiple machine learning services, RonDB handles it all smoothly and efficiently.
Number 4, scalable storage. RonDB is able to handle datasets that exceed the capacity of a single node's memory by utilizing scalable storage solution. Data is stored on NVMe SSDs, accommodating large tables of data while maintaining low latency and high throughput. RonDB ensures that even with large data volumes, it provides consistent performance, making it ideal for applications that need substantial storage capacity without compromising on latency.
While RonDB excels in LATs, one of the biggest reasons we built RonDB was so we could use NDB cluster in the cloud. When HopsWorks was originally released, it used NDB cluster as its online feature store. However, NDB has long been seen as challenging to configure and operate, and it was not built with the cloud in mind. These challenges limited its broader adoption. We knew that a cloud-native key-value store would be an optimal choice. That's why we created RonDB, the cloud-native, next-generation key-value store with SQL capabilities that's easier to use and deploy. RonDB embraces the cloud-native approach. Instead of owning and managing hardware, you can rent computing resources and create a fully managed RonDB cluster with just a few lines of code.
Unlike traditional NDB setups that require complicated configuration, RonDB automates operations so you can focus on your business problem. It's optimized for AWS, Azure, and Google Cloud, turning a complex distributed database into a simple, high-performance system ready for real-time AI. RonDB is a Kubernetes first-class citizen, but you don't have to learn Kubernetes before using it or struggle with convoluted setups. You can use the open-source Helm chart developed by HopsWorks to set up a running cluster on Kubernetes with no sweat.
There are a number of benefits that come with using a Helm chart to deploy RonDB. With Helm, it is easier to update a running application, and it makes Kubernetes much more dynamic and flexible when it comes to utilizing resources. The RonDB Helm chart exposes the user to a small number of parameters that really matter and abstracts away a lot of the complexity in operating and reconfiguring the RonDB cluster. Using the RonDB Helm chart, you can get RonDB up and running in a matter of minutes.
Outside of Kubernetes, you have several options for deploying RonDB. If you want zero setup, use the serverless version on app.hopsworks.ai. This is fully managed and ready in under a minute. If you want more control, deploy a managed cluster in your own cloud account with Hopsworks and Terraform, or use Hopsworks cloud scripts to create clusters in Azure, GCP, or on your own hardware. For even more flexibility, RonDB offers open source binaries and Docker containers, so you can run RonDB anywhere, no matter which option you choose. The message is the same. RonDB's cloud integration means ease of use. It turns a complex distributed database into a simple, automated system that's ready for real-time AI. This allows you to focus on building great applications instead of wrestling with infrastructure.
In order to make it easier for you to connect your application, RonDB supports a wide range of APIs and interfaces, including ClusterJ for Java, MySQL APIs and interfaces, OpenLDAP, REST, and more. You can store your data in RonDB and access it in many different ways, creating new opportunities to build innovative applications. RonDB's REST API server can accept hundreds of thousands or even millions of requests per second, each with a payload of dozens of kilobytes, all while maintaining a response time of 1 to 2 milliseconds, thus providing a high-throughput, low-latency service. One use of RonDB as a high-throughput, low-latency service is Zalando, and they needed a feature store that could deliver dozens of records per request, each response containing dozens of kilobytes. Zalando trusts RonDB to deliver what they need, because RonDB can handle high-demand, high-volume workloads with near-instant responses. This is possible even through RonDB's REST API server.
We purposefully designed RonDB in such a way so that it could be used as a base platform for many different types of data storage. Here at Hopsworks, RonDB is used to store the metadata information in HopsFS and to store data for the online feature store. RonDB enables Hopsworks to access data with incredibly low latency, high availability, extremely high throughput, and scalable storage through the cloud. These characteristics of RonDB are what we wanted to give our customers that use Hopsworks, which is why we wanted to develop RonDB.
Because RonDB meets LATS requirements and is a manageable database in the cloud, it serves as a reliable foundation for a wide range of applications beyond Hopsworks. For example, telecom providers could use RonDB to store data about users and the services they use in a single database for various processes such as number translation, update HLR information, and more. Gaming applications could use RonDB to store data on gamer profiles, game statistics, and the real-time status of ongoing games. The financial sector could use RonDB to track millions of transactions per second, which is incredibly valuable for fraud detection, stock exchange data, and more. Developers and organizations can use RonDB to build a variety of complex data-driven applications that require high speeds, quick response times, and the ability to manage large loads of data. RonDB's customizable flexibility will serve you well, no matter what your data requirements are.
As we mentioned at the beginning of this video, we have just released the newest version of RonDB, RonDB 24.10. This update aims to enhance performance, scalability, and ease of use. With this new version comes 11 new features, so let's take a look. Number 1. Interpreter enhancements. Our first feature we have introduced are some new interpreter functions. These new functions now support read, write, partial updates, and appending to binary fields. The interpreter runs on 64K of memory per execution, giving developers more freedom when developing against RonDB. Number 2. Our Redis API, Rondis. The next feature we have introduced to RonDB is Rondis, a Redis-compatible API allowing users to use familiar Redis-compatible commands while enjoying RonDB's speed and high availability.
Number 3, a new REST API server. The newest release of RonDB comes with a new REST API server. This new server is completely rewritten in C++ and is up to 10 times faster than the previous version that was written in Go. This server allows fast access to data through RonSQL, which we will introduce in just a moment. Number 4, time to live. This is a new feature in RonDB 24.10. Users can now set rows to automatically expire based on a user-defined timestamp. This feature simplifies window-based analytics and real-time data cleanup. Number 5, Pushdown Aggregation. With this feature, aggregation queries can now run directly in RonDB data nodes. This completely bypasses the MySQL servers and significantly reduces latency, making it ideal for real-time analytics. It is available both via the RonDB API and via RonSQL, and currently supports single-table aggregate queries.
Number 6, RonSQL. RonDB 24.10 brings the release of RonSQL, a new SQL over REST interface. Users can use RonSQL to execute SQL queries directly over the REST API. This feature enables fast, scalable access to relational data without needing a MySQL frontend. This feature is still being developed, and we are expanding it to support more types of queries. Number 7, rate limits and quotas. This feature can be used to limit memory, disk usage, and concurrent transactions. Rate limits and quotas are a must-have for managing multi-tenant workloads. Number 8, faster recovery with parallelization. RonDB 24.10 now makes recovery 2 times faster by using parallelization to process recovery steps concurrently.
Number 9, large batch size for scan queries. We have increased the max batch size for scan queries from 992 to 4096, improving the performance for scan-heavy operations. Number 10, new interactive local domain ID command. We introduced local domain ID in RonDB, enabling the cluster to be deployed and operate reliable across multiple availability zones. Number 11, automatic memory management in containers. The final feature we introduced to RonDB in 24.10 is automatic memory management when you are running in a container, making a more efficient use of your cloud resources. Together, all 11 of these features make RonDB 24.10 more robust, performant, and cloud-native than ever.
Today, RonDB is the fastest key-value store available in the cloud. We've added important capabilities for AI workloads, such as pushdown aggregations and nested left joins. We've also made RonDB easier to integrate with applications by adding a REST API, a Redis API, and a new SQL API. Finally, we've made RonDB easier to install and operate through Kubernetes Helm charts. If you want to learn more about RonDB, go to rondb.com. RonDB, your real-time database for the AI era.